now that we have spent some time, now that we've spent some time talking about how to translate English into math, right? Now we're going to do it. We're going to do it with a real word problem. So we're going to do the whole thing, and we're going to start to see, oh, this is really easy. Pretty amazing. So these are called number word problems. I find these so fun to do. Of course, I'm a math teacher. I'm kind of weird. But you might too. Number word problems. A lot of people do. They're really kind of fun. Problems. And I don't like that pen. I'll try a different one. Okay. So what I'm going to do is I'm going to write a problem, and I want you to be writing in your notes as I'm writing it, okay? So that we're not going to spend too much time waiting for you guys to catch up writing the problem. So write it as I write it. So here's our first one. I'll say it out loud so you don't have to necessarily look up here. This is our first problem. One number is 5 times as large as another. Period. Their sum is 36. Their sum is 36. Find the numbers. Okay. Has everybody finished writing it down? Okay, so let's look at this. One number is 5 times as large as another. Their sum is 36. Find the numbers. How many numbers, John? How many numbers are we talking about? 2, right? Does everybody agree with me? Yeah. One number and another number, right? There's 2 numbers. So we have to have 2 things, 2 numbers here in expression form, in algebraic expression form. So which one is the foundational one, Zane?
I was going to say that I know what the answer is.
Great. I don't want that.
Okay.
I don't care about the answer yet. I care about what is the foundation. Stick with me though, Zane. Which is the one number? It says one number is 5 times as large as another. Which is the foundational one? One number or another?
Another number.
That is 5 times as large as another. If I knew this one, I could find that one. That's my foundational. So this is what I suggest you do. You underline your foundational number and you put an X over it. That always tells you that that is your foundational number. So I'm going to come over here and I say my first number is X. Everybody with me? What's my second number? The other one number is 5 times as large as that. So what do we have? 5x, right? 5 times x, 5x. So I've got 5x. So everybody's with me, right? Yeah. There are my 2 numbers. I want to see these numbers. I want to see both of them, what your expressions are for both of them. Do not do this in your head. I want to see this stuff on paper. So always on the top left, you put your first 2 numbers there. This is going to be useful later, okay? It's going to be useful now and later. So Bella, now.
I have a question.
Yes.
Are we going to do like 5x and equals 36 and then do the problem?
Well, now we're going to, so we have just dealt with the first line because we have figured out our 2 numbers, right? We figured out our 2 numbers by reading just that first line. One number is 5 times as large as another, which is the foundational number. That's my x. And the other number is, one number is 5 times that. So there we go. Now we got to deal with this sentence. Their sum is 36. Amaya, how would I do it? Okay, great. I want to know the process though. It's good that you got the answer, but we'll see. Just hold on to it and we'll see if you're right, okay? So what would I do for this? Their sum is 36.
So 5x plus x equals 36.
Aha. So their sum means we're going to add these 2 together, right? Right? So I have 2 ways. I could do it like this if I want to, plus 5x plus x is 6x equals, is means equals, right? Is equals 36. Or I could do Skylar's way with saying x plus 5x. I'm adding these two together equals 36. All right? And if I did that, if I have 5 apples and I add another apple to it, I have 6 apples, right? So same with the x's. I have 6 x's equals 36.
So
Now what do I do?
1x is one of them, and then 5x is the other one? Can you put the 1 in?
Wait, I don't get this.
I know what X is.
So 1x is like, I mean, just an x.
Can you think about it?
1x,
as
is, just so you know, 1x is the same as x.
Right, but when you're adding it,
Yes, think of it as 1x plus 5x equals
so
6x.
it's not 5x when you add it, it's 1x. It's not 5x, it's not 5x. Oh, okay, never mind. Like what I was going to say is, it's not, because if you have a 0 there, then there's no x.
Yeah, so when there is, so what's that number called again that's in front of the x?
A number.
Coefficient. Right. And so when there is not a coefficient in front of a variable, there is one, but it's hidden. There's only one hidden coefficient on the planet.
1.
So far. That's the only one that we've found so far. And it's 1, right? And so there's a 1, right?
Isn't there a negative 1 though? That's a hidden?
Only if I did this. If I had a negative x, then it would be negative 1x, right? But I don't have a negative, right? Thank God. I don't have a negative. So I have 6x equals 36. Now I want to divide by 6, and I get x equals 6, right? Yes?
X
Is that what
6.
you, okay. So now am I done?
No.
No.
Look at the last sentence. It says find the numbers, right? There's a plural there. So I go back to my original numbers. My original numbers that I wrote, Jackson. I go back to these original numbers I wrote, x and 5x. And I know that x is 6. So my first number is 6. My second number is 5 times 6, which is 30. So those are my two answers. So I would say the numbers are 6 and 30. And I put it in a box or a circle, and I'd be done. Yes?
I did it like, how did you have to do it both ways with me to get like, cause I did it just the way on the left.
No, all you have to do is this. Divide by 6, divide by 6, x equals 6.
You only need to do it one way.
You only have to do one way, whichever way you want. I personally like this way because I get it here immediately. Otherwise, I have to rewrite everything and then get it to there. You know what I mean? I have to add my like terms, right? Make sense? Yes. Yes.
I got 7.2.
You were wrong.
How did you get 7 points?
Because you divided the same number, then it would be 7.2. Because 5 times 7.2 is 36. But that's not what it's asking. Because it's asking
It's
what
asking
plus
for two
what.
numbers.
It's asking what number times
Plus another number.
what number times 5 is
Does
What
7,
number? So the x
does
plus.
It's asking
7.5
for
or
one
whatever it
number
was
plus one number.
plus 5 equal 36?
But it says their sum is 36.
No, 7.2 plus 7.2 times 5 is 36.
Yeah, but
So it says their
7.2.
sum is
Okay,
36.
oh yeah, the 7.2 plus
Sum
5 does not equal 36. Their sum is 36. See what I'm saying?
I get it.
Yeah. So that's why you've got to set it up like this. Okay. So that's the first kind. I'm afraid I'm running out of time again.
You are.
Always what happens.
Does it happen with the 8th
Can I? Well, yeah, it's because we've had a shorter classes lately because of Fall Festival. I'm not used to the short classes. It's hard to, especially when you have lots of things planned. But so, what if I did? Let's just set. Well, let's do one. Here's another one. We're gonna do this kind of fast. One number, and I may just have to have you do one side of the homework or something. One number is 6 less than another. Their sum is 20. many numbers am I looking at here? 2. I've got one number and another number. Which one am I going to underline? The second one, this one? Yes, and I'm going to put what on top of it? X. That always tells me that's my foundation, right? So I know my first number is X. I'm going to write it here. And then underneath that, I'm going to write my second number, which is?
6.
X
It
minus
says
6.
6 less than X.
So,
X minus 6.
Yes, exactly. X minus 6. Beautiful. Then it says their sum is 20. Somebody else. How about Isa? Their sum is 26. What would I do? I mean, their sum is 20.
So you
Sorry.
would add those two together.
So I'm going to do it this way. I like the vertical personally. It's just faster for me. X, because I have my X's. See how my X's are lined up? When I write these, I don't write it like this. I don't go like X is my first one and X minus 6 here, like that. I don't do that. I do it where my X's are right underneath each other. Then it makes it really clear.
No, you have X plus X minus 6.
It's 2x minus 6.
So X plus X, I have an apple plus an apple. I have 2 apples. I have 2 X's minus 6. That's my sum, and that equals 20.
oh, I know how to do it now.
Right? And now do I subtract 6 from both sides?
You add.
I have to.
You guys all see that? You've got to add 6. Whatever this sign is, whatever that sign is, you got to put the opposite sign there. So you're adding 6, adding 6. 2x is equal to 26. Divide by 2, divide by 2. X is equal to 13. Am I done?
No.
No.
You do 13 and 13 minus 6.
And when you add,
Minus.
So I'm going to bring this back up here. My x is 13. So I know this number is 13. This one is 13 minus 6, which I think is 7. Am I right?
Yes.
Yay.
So those are my answers. So I'm going to say the numbers are 13 and 7. And I'm going to put a box around it and I'm done. Easy enough?
Yeah.
Do you think I have, can I just try to squeeze in one more?
No.
Yes.
I think you have time.
Okay, so I'm gonna, can I erase this?
Yes.
Is everybody okay?
Yes.
I can? I mean, you know, they might be willing to just extend break just a little bit so that,
Yay.
because it's not fair because I'm always getting the shorter class because we're running over in the morning. Right? So 3, I'll try to make that happen. 3, one number, so write this down as I do it. One number is 4 more than another. Is 4 more than another. Period. 6 times the smaller is equal to 2 times the larger.
What?
Just write it down. Comma, increased by 4.
And
Find the numbers. Okay. I know this is a little confusing, but you're going to find that if you do exactly what it says, it won't be that hard. What are my 2 numbers? One number and another number, and I'm going to underline this and put an X over it, right? And over here, I know my first number is that X. My second number is what? 4 more than.
So 4x.
4 more than.
X minus
plus 4.
X plus 4.
X plus 4. Okay, now, the next sentence says 6 times the smaller. Oh no! How do I know which one's smaller?
X?
You do x times 6,
Well, x
Oh.
is obviously smaller.
Oh
than
yeah,
plus
x
4.
is, isn't this obvious? That has to be smaller than this. This is 4 more than this one, right? Right? So this is my smaller one, small, and this is my big, right? So it says 6 times the smaller. So 6 times the smaller, which is x, 6x. Wow, so what I just did, 6 times the smaller.
Wait, do we write 6x underneath x plus 4 or not?
No, just write it in a new, you're writing a new equation now. 6 times the smaller, 6x. And then it says is equal to, what do I put there?
Equal.
Equals. Do you see what I'm doing? I'm just going left to right. And it works.
Equals
It says 2 times the larger. How would I do that?
2x plus 4.
2,
X plus 4
but,
plus times
but
2?
the larger
Oh, wait,
is,
I know.
the larger is this blob. It's a binomial. So I've got to do 2 times parenthesis. I've got to have this whole blob inside the parenthesis. X plus 4, parenthesis.
Which is 2x plus 8.
Yeah, okay, but let's keep going. Increased by 4. So now plus 4. Look at that. There's my equation.
That's crazy.
Does that make sense? 6 times the smaller is equal to 2 times this blob, which is the larger, increased by 4. So now I just do my distributive property. 6x is equal to 2x plus 8 plus 4. Now I'm going to, I see my x's are on both sides of the equal sign. That's not good. So I'm going to subtract the smaller number of them. Subtract 2x from both sides. Right? Then I've got 4x is equal to 8 plus 4, which is 12. Now I divide by 4. Divide by 4. X is equal to 3. Okay? So now I go back to my 2 original numbers. The first number is 3. The second number is 3 plus 4, which is 7. So those, then I'd write my numbers are 3 and 7. Okay? So.
Okay. I think
Very logical.
Alright guys, so homework right here.
Homework time.
I thought you were going to say something else.
Okay, so now.
Beautiful.
I know, much swagger.
First thing in the morning.
Can I have my homework?
You don't have to take it.
Like, because we're insane, that's why. We're all insane. It's not accepting
No, she's a good student. I know. Oh shoot, I didn't turn this off.